Okay. Next, so collinear vectors we studied. Next, we need to study coplanar vectors. Collinear vectors are two vectors whose line of supports are parallel. Okay, in which two types are there: like vectors and unlike vectors. Like vectors means same. Like vectors means same direction. Unlike vectors means opposite direction. Collinear vectors and parallel vectors both are same. Okay, same meaning, and that doesn't mean that they have the same direction, either same direction or opposite direction. Parallel vectors doesn't mean that they have the same direction. Okay, meaning is their line of supports are same. Okay, next one is coplanar vectors. What is coplanar vectors? Three vectors, okay, are coplanar if they lie on the same plane. That's the meaning. First thing is these two vectors. This is vector A and vector B. What are they? Are they coplanar? They are collinear. Since they are collinear, they are obviously coplanar. What is the meaning of coplanar? Okay, just assume that so many there is a table, and on the table there are so many pen. Okay, so many pen on the table. Then all these pens are coplanar. Okay, coplanar. I hope you understood. Or you take a board. On that board I am drawing so many lines. Okay, all these lines are coplanar. Okay, and you assign them direction, then all of them are coplanar vectors. So that is coplanar vectors. So what is the meaning of coplanar vectors? Coplanar vectors means three or more vectors are coplanar if they lie on a plane. Okay, on a plane. Now here so many things you need to understand. You may think this is a very simple thing and just read the definition and leave it. Actually it is very simple thing, but the problem is students don't have the proper clarity about coplanar vectors normally. Okay, so listen very carefully. You take any two vectors, they are coplanar. Take this vector A and vector B. Are they coplanar? Yes. They lie on the surface on which I am writing all these things. So they are coplanar. There is no doubt in that. They are coplanar. Now the question is, okay, assume that this B I parallelly moved to the Z direction. Like that you think this is X axis, this is Y axis, and I just took Z axis, and B I moved parallelly. Then also these two vectors are coplanar. Okay, now you take this. Are they coplanar? Yes. Now assume this vector B is moved in the positive Z direction. I am talking about upward direction. Okay, from this plane it is moving away. Then also it is, these two are coplanar vectors. Okay, why they are coplanar vectors? Because we are dealing with the free vectors. Free vectors can be moved parallelly. Okay, so any two vectors are coplanar. You take any two vectors, they are coplanar. Okay, for more clarity, see, you take this vector, this one, vector A, and this one, vector B. Are they coplanar? Yes. Okay, if I take this as X, this as Y, and this as Z, Vector A and vector B are lying on yz plane and they are parallel. Parallel vectors are automatically coplanar vectors because they lie on yz plane. Is it clear? Now what about this vector? Let me take it as C. Vector B and C, are they coplanar? Yes. There is a plane, this plane. Okay. O, A, B, C, D, E, F, G. Okay. Or I will do it in another way. Make it A, B, C, D, P, Q, R, S. Now listen. You see the plane containing P, Q, R, S, S. So B and C are coplanar. Okay, no doubt. B and C are coplanar. Now you see the plane A, D, S, P, A, D, S, P, A, D, S, P. A and B lie on that plane, so they are coplanar. Now you take A, B, C, C and A. C and A, are they coplanar? A and C, are they coplanar? You can see a plane Q, R, D, A. Q, R, D, A. Okay, Q, R, D, A. Just like a section of this cube. Okay, QRDA, that's a plane, and C and A are coplanar. Now you consider this D. Which vector? I am talking about QR vector, which is C, and CD vector, which is QR, which is C, and DC vector, which is D. Are they coplanar? QR, vector QR and DC, are they coplanar? Can you see any plane which contain both of them? No, you cannot find any plane which contains both of them. That's true, there is no doubt in that. But we are dealing with the free vectors. So this DC I can move parallelly, and DC is equal to SR, correct? DC is equal to SR. So you can see QR and SR, are they coplanar? Yes. Why? Because QRSP or PQRS. Okay, PQRS. So understand this, QR and DC, are they coplanar? QR. If I use localized vectors, answer is no. But we are not going to use localized vectors. We are dealing with only free vectors. So QR vector and DC vector, okay, are coplanar. Why? Because I can move this DC vector, that is D, vector C and D are coplanar. Now let me tell you this, not C and D, any two vectors which we are dealing are coplanar vectors. Okay, any two vectors are coplanar. We are not dealing with the localized vectors. We are dealing with the coplanar vectors. So that's it. Any two vectors. So I can move this CD parallelly and make it SR. Okay, I can move DC parallelly and make it SR. Okay, clear? So I hope you understood this. Any two vectors are coplanar. Now, what about any two parallel vectors? Two parallel vectors are obviously coplanar. Any two vectors are coplanar. Okay. Now what about three vectors? What about three vectors? Three or more vectors are coplanar if they lie on a plane. Okay. So that's the concept. Okay. So this vector, this vector, this vector, are they coplanar? Yes. Understood? Okay. So that's the logic. Now we will study about coplanar vectors again. You see I cap, j cap, k cap. Are they coplanar? Are they coplanar? I, j, k. Can you make them coplanar? By moving j or k, can you make them coplanar? No. Okay, I cap, j cap, k cap are not coplanar. They are not coplanar. Okay, three mutually perpendicular vectors will not be coplanar whatever you do. Okay, understood? Now I cap, j cap, 3i cap plus 4j cap, are they coplanar? Yes, all of them lie on which plane? XY plane. They lie on XY plane. Okay, clear? So that's the logic, that is coplanar vectors. Okay.